All right. So welcome, Math 112 students. This is ultimately going to be your time. I have at the ready here a collection of the 4 final exams from my archive. So it would be good in a moment. And one person has already asked a question, so we have one on the list. But in a moment, I'll kind of have us, blow up the chat with some questions, and then we'll go through as many of those as we can, trying to see what we can do. I did post a collection of videos on these topics. So if you find you need, because during these review sessions, we're not going to be able to cover everything. And so that's why I make the review videos ahead of time in case you need a little more. And that's here. So if you go through here, you'll see like sneak peek, and then I have topic by topic in there. It doesn't mean you need to watch all those, but if you're struggling and don't remember how to analyze function,
Over the
there's more
Adriatic
details here.
on a routine surveillance patrol headed toward Istria.
I'm trying to mute somebody came on there. Okay, so in a moment, I'll ask you for questions on those topics. And just know we can, and I may stop when we get to a particular topic if I anticipate what some of the bigger questions will be, and I'll say a few general things. All right, that is the plan. Our exam is Thursday, 8:30 a.m. in Bagley, our normal classroom we've been in. All right. Beyond that, you still can ask questions on the discussion board. I did post an announcement. One of your TAs said he's willing to offer office hours from 1 to 3. So a couple notes. Besides this time, there are office hours Wednesday from 1 to 3 p.m. in low 102. So I wanted to give you some in-person options. But really at this point, I want you to be studying on your own, forming study groups. Okay, so check all that out. Definitely check out what I just posted where I gave kind of a sneak peek of the exam. This just reiterates what I've already been saying about what's on each page. Page 1 is going to be derivative and integral skills. Page 2 is going to be definition, derivative, tangent lines, and continuing with those skills. Page 3 will be areas as well as possibly consumer or supplier surplus. Page 4 and 5 are the analysis, but 5 will in particular have some sort of business functions, and 6 will be multivariable. So that's what we know is coming. Okay, so my intentions here, I'm going to make a few notes. And maybe before we launch in, I gotta adjust my OneNote here briefly. Just to make a small list of questions to start with. So if you could, feel free to blow up the chat now with your questions. I have Winter, and I'm going to go through and try to grab a few. Winter 18, question 3B was asked by Sasha. Thank you. I'm guessing that's some sort of analysis question. And then we have a spring 23, number 5. And I don't know what that is. We'll have to look. My hope is we hit quite a few topics. We're going to go for at least an hour and a half. I'll happily answer lots of questions now. We don't have to feel rushed. Anyone else we want on our initial list? Those are the only 2 I have in the chat. At any point, 2, you can unmute. Let's see. I see spring 23, question 3, part 2, number line. So that must be an analysis sort of question. Good. And then winter 18, 3B. Right. Okay, let's take a look at that. I'm just going to kind of take a note. And I don't have to put maybe people, I don't want to discourage questions by putting people's names up here. I just wanted a note of what we were about. Okay. Winter 2018, it was spring 2019.
I had this like silly putty that I used to play with.
let's start with these. At any point, you can ask questions there. You can even unmute and ask questions. You can raise your hand, whatever. So I'm going to start with this, kind of see where we're at. We'll kind of, after a couple questions, we'll come back, reevaluate, and that's our plan. Okay. So winter 2018, let's go find it. Winter 2018 3B. So here's winter 2018. Here's 3B. Ah, yeah, okay. So I definitely want to say a few things as we hit on a problem, just to sort of know the context. So here's this question 3. We said this is winter 18. So this here was not the question, but that's a functional notation question. And that comes about from our understanding. I think I mentioned in class that this will be slightly less emphasized, but let's address it here in a second. And let's maybe mention some of the other parts along the way. And if I start to do a question and it's not the one you intended, just let me know in the chat or raise your hand. But I just would like us to look at part A. Now, if I'm going to ask part A on the test, I probably will divide by H because that's actually the application. That's where we use this. This expression is actually where calculus starts. And this represents the slope from t to t plus h, which is actually what we call, in this case, the average speed or the secant slope. And that's that foundational stuff. That was back when we were first learning what a derivative was. So I would like to see that just to execute. The question itself asks just for the numerator. But let's play this game. I'll write the function a little bigger. Sometimes when I print to one node, it looks a little blurry. So I'll make this a little bigger. T minus 3t squared. So I'd like to do part A and then we'll address part B. That's my plan. And we'll do a partial derivative. Yeah, we'll keep that in mind. See if you can find a particular one, Naru, about that. Okay, so think about that for a second. I'm just letting you do the first part. This thing we're about to do is this part 2. So I'm going to try to reference the more detailed review. If you find something we do today and you want to look at it in more detail, that's in the discussion board. And this would be the part 2, definition of the derivative, 9.3 stuff. Okay, so let's do it. So I do think this is an important skill just in general. If someone gives you a function and changes the input, how do we use it? And when we write this, this is calling on the function twice, is what we say. So I'm going to write the function twice, and I'm going to leave space. So 18, I'm going to leave space. Minus 3, I'm going to leave space. 25. So there I wrote down the function once. Let's put little parentheses around it just to say, okay, there's my function. And I'm being asked to plug in t plus h. So it's just a reminder, this was a big thing we did at the beginning of the term a lot. And then I'm going to call on the function again. So I could argue that this is almost more important than anything else we did, because you're going to work with functions if you go on into a course that uses math in any way. So functional notation is pretty valuable. Okay, that's what a of t plus h minus a of t would be. What am I going to put in these two spots? Tell me in the chat. What goes in those two spots, just to see if you're still here. I'll try to find things that are easy to type in the chat. Yeah, it's this. These instructions, it might be small to see, but the instructions are saying put in a t plus h. So in those two spots, there should be a t plus h. That's what that means. So that's what a of t plus h means. Go find the function a and plug in t plus h. That's what it means. But we haven't gotten that yet. Okay, so then the other spot we're plugging in t. That's what this means. Write down the function, plug in t. Let's plug in t. The question didn't ask you to divide by h, but I am going to do that at the end just because that's what I'm going to ask you on the test. So the rest of this becomes a little algebra exercise. And we have a few different things. In fact, I think we'll just change the question now so it looks just like it would on the test. So let's divide by h as well, even though this one didn't ask for it. So let's pretend this was the question. So go ahead, if you have a piece of paper, this would be a good opportunity to just practice this since you know this is coming on page 2 of your exam. Can you expand? It's a little algebra exercise. So expand. Let's just letting you do it. This is a great chance to just practice if you haven't practiced this yet. And then we'll move on to part B, and then we'll do something else. And then later, if we want to come back and do another one, we can. If you do everything correct, this will all cancel, and this will cancel. And there's even a third way to check your work, which is that we should be able to get the derivative from it. So there are 3 checks of your work. Check 1, check 2, check 3. So even though there's quite a bit of algebra, if you build in these checks, you can know if something went wrong. Okay, so let's start expanding. So we're just gonna, this take a sad song and make it better. We're gonna clean this up step by step. It's gonna get worse for a second, and then it's gonna get better. The biggest challenge is expanding this term. So let's talk about that for a moment. T plus h squared. I'm going to do something here. Maybe another thing you can post in the chat. When you expand t plus h squared, you do get t squared, you do get h squared, but you get something else in the middle. What is that something else? Yeah, it's 2th. That's that middle term. And here, this will be just like when we're in the classroom. Because in the classroom, I always make this bad joke about monkey facing this out and no one laughs. Now it's even worse because I can't hear anything. Okay, t squared, h squared, and then 2th. So this is 2th. Okay, so let's talk about where we're at. -3, and then this thing. Oops, I made a typo. (2th) plus h squared. So this is really the hardest part, but this is why I wanted to do this. I know this wasn't the question. So there's that first parenthesis expanded. Sorry if you're hearing my son in the background. Okay, so then we are going to distribute and see what happens. -18t. So I'm glad that we have these little checks of our work because there is plenty of room for error here. And so let's sort of check along the way. We're expecting everything from the second term to cancel. Okay, that cancels with that. That's good news. The 25 cancels. That's good news. But it appears the 3t squared didn't cancel, at least not yet. So let's keep going. So we have 18h minus 3t squared minus 6th minus 3h squared. So this is a little algebra challenge. Not hidden, but part of your exam. And let's see if this canceled. It did. So check 1 is done. Everything from that second piece canceled. That should happen because they appear in bold and you're subtracting. So let's kind of take stock of where we're at. And you know this is coming on page 2 of the exam. It's probably your biggest algebra challenge on the test. But since you know it's coming, you can handle it. Any questions so far? So I just expand. All that really happened was distribute, distribute, cancel. thumbs up if we can go forward. And if you can find the thumbs up.
Wow. Doing a shot there. Okay.
All right. So now we can cancel an H. How do we cancel the H? We can cancel one out of each one. This is just doing a reminder here. You definitely don't need to show me all these steps. But if you forgot, here's how it goes. You can cancel one H out of each one. So I get, if you divide by H, you would get this. Now the original question didn't ask you to divide by H, but I added that in. So check 2. The H canceled. And then there's one more way to check our work. And the way to check your work is that we actually know how to get the final derivative. If this question didn't ask for the derivative, but if the question had asked for the derivative, we had another way to do it. So let's go back up to the beginning and think about what the derivative should be using our shortcuts. And that's actually fairly easy. I think you could type it in. So what is the derivative of that original function? I'll rewrite it here. This was t squared. So go ahead and write that in the chat. I think it's something you can easily type in. What's the derivative of 18t minus 3t squared? I assumed it was a typo. Yeah, 18 minus 6t. Oh, some people are typing it in privately, so you can't see there. The chat doesn't get posted with the video later, so if you're worried about that, don't be worried. So that's what the derivative should be. So we can use that to check our answer here. They shouldn't be the same, but they are the same when you plug in what? So if you plug in h equals 0, this represents the slope from t to t plus h. And this represents the tangent slope, which happens to be the slope when this has h equals 0. That's how you can check your work. If they don't match up, something went wrong. So I think that problem is tamed a little bit if you understand where that all comes from. So that accomplishes a few things. It's a little bit of theory. It shows you where the derivative comes from. It shows you, it gives you a chance to do functional notation. So I'm really asking, I'll be asking that on page 2 of your exam, mostly to check a few different things, a few different skills. Okay. Are we all right? So we know that's coming, page 2, the middle of page 2. We're going to ace that one. But let's put that out of our head and move forward, if you'll allow me. So the main use of this was to find the derivative back when we were first finding it, which gives you the instantaneous rate or the slope of the tangent, which is what part C is about. So what is part C asking? And then we'll do part B. Part C is asking you to plug 5 in to the derivative. Yeah, I'll post the recording after. Usually somebody's asking about the recording. What happens is it takes Zoom usually an hour or 2 to process it, and then I'll post it. I'll probably post it privately on YouTube and then put a link from our discussion board to there, so only people in our course can view it. All right, so this would be asking for the derivative at 5, which is 18 minus 6 times 5, 18 minus 30, whatever that is. Part B was really a question from section 9.3, so it makes sense if you're confused by this because it's been so long. We haven't been talking about average rate much this term because almost the entire term has been about tangent slopes. Average rate means secant slope. You actually don't need calculus to do this part. This is just a definition from the first week of the term. So if you don't remember, average rate is this. It just means slope. Now, in this case, we're talking about the function a, and we're talking about 2.5 and 0.5. So the tedious way to do this question is to find the change in output and divide by the change in X. So that will give you your answer, but that's kind of tedious to do because you'd have to plug in a 0.5 here and 0.5 here, compute it, plug in a 2.5, 2.5 and compute it. So this dates back to the beginning of the term. It's this question. Let me see if does this work? Let's try it. Just a second. I'm not frozen. Just seeing if this works. So this dates back to these questions, like the first problems of the term where you're doing the average rate for that function. That's why people have forgotten that piece. So it's plug in, subtract your y, subtract your x, done. That was those questions. Okay. Anyways, there's another way to this question, which is you could say, well, we just figured this thing out. We used to do more of this. That's why I said this will be emphasized less on our test, but it doesn't mean it's something to be afraid of. Because we've already done all this work to simplify, another way to do this problem is just to figure out what t and h are. So let's think about this for a second. What is in the place of t? Tell me in the chat. Just see if you're with me. T is 0.5. So you would say, oh, t is 0.5. What's in the place of h? So this is 0.5. It's a little puzzle. What do you have to add to 0.5 to get 2.5? 2. So the short way to do this problem is to say, well, we already simplified this formula. All we got to do is plug in 0.5 and 2. So no, I'm not planning to ask about that on the final, but I don't want it to be something we're afraid of either. We do need to know functional notation. So anyways, that was that. That's what that was about. Again, we used to have more of that. The final exams are not a perfect fit with what we've done. That's why I've been making all these videos to give you more guidance about what to study. All right. I'm going to move past that question because specifically the question was about part B. So I would argue, let's see where we at here. I'm going to label this. And we can go back if there's more questions. I'm just labeling what we did. I would call that a definition of derivative question we just did. And that was something where we had to do something of this sort and understand how to simplify, and that gives the derivative. There's a question privately in the chat. I'm just trying to keep up as they come through. So that's the program. Some of the questions will go much faster than that one, but since that was a topic you know is coming, I thought it was worth a little extra time. And again, if you want more on that, read this. Definition of the derivative, part 2 of my reviews. All right, that's the program. So we're going to move on to spring 23.5. Good? Thumbs up, you with me? Spring 23, number 5. And away we go. Spring 23, number 5. This is spring 23. Sorry for the scrolling. Ooh, that one's easy to answer. So I can definitely talk about these, but I'm going to save something like this for the end of the video, end of the review, if someone wants to stay on and discuss it, because that's not going to be on your test. Those graphical questions. I was in preparing for the writing the final, I realized we only have one question that was graphical in this nature on our homework this term. I didn't realize so many of these were removed. And so I don't think these are appropriate for our final. That doesn't mean they aren't interesting, but we only did one. So the answer is we're going to skip that. And I go through and say that in this video. And this video right here, I go through all 4 of my old finals and I cross off the one. So if you're curious about what other ones do we get to skip, just watch that video. It's a fairly short video. I go through and I cross off these ones. Did I hit on the right one? I can't remember who asked that. So you can skip that. I'm happy to come back to it, but I want to focus on other things and only talk about that at the end if someone's curious. I do think this doesn't mean you do need to know that an integral is an area. But back when we taught this, we had students like estimate counting with boxes, and we didn't do that this term. So I'm going to skip that. So this would be graph estimating. And the answer was that we are skipping that. Okay, so let's look at spring 23. I see there's enough. I'm just trying to kind of make notes as I keep up. And if I missed your question, there'll be time later, but I'm going to keep going in order. So spring 23, 3, part 2. With me, I'm going to jump back here. Spring 23, 3. Okay, so somebody asked this question. This will be on page 4 of your exam. I'm not saying this exact question, but this is what I would call an analysis question. To me, this is the big skill I want students to take, which is if someone hands you a function, I like to say a calculus student should be able to chew it up and spit it out and say what flavor it is. So you should be able to know the behavior of those functions using the tools we learned this term. And in particular, we talked about 3 types of questions, and I do a full review of the 3 types of questions. Let's see, right here, the 3 types of analysis questions. The first type I categorized as anything that has to do with max, min, increasing, decreasing. Oh yeah, I could do something with the horizontal point of inflection, sure. I don't know if it comes up in this question, but at the end I can pull one up. And then we have global max and min. So we should have a plan of attack for these sorts of questions. And then we have concavity questions. Concavity and point of inflection. Somebody's asking in the chat about horizontal point of inflection. Well, we can talk about that, but I don't know that either one of these examples has it, so I'll grab that up. Okay. So this first question is a global max and min. So we should definitely have a plan, but I believe the question that was asked initially was part 2. So let's start here because that was what somebody was asking about. So find the longest interval, let's read it, on which f of x is decreasing and g of x is also decreasing. So we want them both decreasing. That's this first type of question. So what do we do in the first type of anything that's about increasing, decreasing, local max or min is what I would call a first derivative analysis question. Meaning we want to know the shape of the graph. Because if you think about it, if you know where the local max and min are, then you also know where you stop increasing or decreasing. This is 2 separate questions. The first question is when is f of x decreasing, and when the second question is when is g of x decreasing. So here we go. I'm going to write f of x here. Write g of x here. This huge long mess. Second, somebody's got unmuted there. And so the moment you see max, min, increasing, decreasing, what do you do? So this is really what if I was a student, I'd want to be able to see that question and immediately have steps. So anything about, in fact, you can even clump these together. All of these questions, those 2, you do the very same first thing. So in both of these questions, the very first step is the same. So think about what that first step is. So the moment you open up this page of the test, you know what the first step is. What is that first step? And it's nice to just have that automatic, because then you can step back and think about what you need to do. Anything about increasing, decreasing, max and min is a question about slope. We're going to take the derivative. Take the derivative. So I would argue that that's not something we want to be taking time on our note sheet for. And really, this is what I want calculus students to have in their head, which is the function gives you the height, the derivative gives you the slope. And for a lot of questions, the slope is easier to work with. Okay. The next step is also the same for both of these. If you want to know when something stops increasing or decreasing, or you want to know when it's a max or min, you're going to set when it's equal to 0. We're finding the bumps. That's my casual way of saying it. Now, we would call that a horizontal point of inflection, the thing I just drew, but our graph doesn't look like that. So anyways, did I know? Oh, thank you for catching my typo. Appreciate that, Grace. Okay, so now we have two jobs. I need to know when this is 0. So for me as a student, I would see this page and I would be thinking, take the derivative and set it equal to 0. Take the derivative and set it equal to 0. Take the derivative and set it equal to 0. So I was always a fast exam taker because I would always have a plan ready before the exam and be like, okay, I see this question, I know the first step. And that way you're not wasting time reading things, doing things that you know are coming. That's how I always thought about it. I just did those things and then I worried after that. Okay, so when I solve this, I get 2x is 8. So I think I get x is 4. How is the derivative of this? Good question. So we have a question about little detour here. A question about the derivative of this term. The number one thing to remember about derivatives when it comes to powers is the power always goes down. So the rule is bring down the power and subtract 1. So when you're doing this derivative, it becomes nx to the n minus 1. So in this case, what happens when we take the derivative? It's going to be 4/3 times 3x squared. And what is 4/3 times 3? And I have noticed that sometimes that's where the stumbling block is. It's those fractions, but 4/3 times 3 is 4. But that's a different review. Does that make sense, Nicholas? Nick? Great. Okie dokie. Okay, let's finish the first derivative analysis for f. So here's where things are different between these two questions. So when you're doing a local max and min, or an increasing decreasing question, it's about what's happening at the bumps. A global max and min doesn't care about what's happening at the bumps. It just cares about the output. So to me, the only difference between these two is whether you're plugging into the original function to get the output or you're doing the analysis. Yeah. Okay, so let's do this. We're going to draw a little number line. We're going to put a 4 here. And what I'm doing is I'm thinking about the picture without actually drawing it. When I say that, what I mean is I'm pretending this is the x-axis. Here's the y-axis. And I know the only bump can be at 4. So that means the graph is either going to look like this, or maybe it looks like this, or maybe it does something else and flattens out. That's the other weird ones where it flattens out for an instant. But if all I need to know is that, I just need to know when it's uphill and when it's downhill. So that's when I'm doing this little analysis. I think this is what the question was about, so I'm taking a little time here. And this is where it's key that I remember that the derivative is the slope and the original function is the height. So I'd like to use the fact that I know the slope to figure out what the slope is before 4, whether it's positive or negative. So I'm going to consider the slope if I plug in a number less than 4. And sorry if I'm doing it too slow, but I'm trying to get everybody on the same page here. So pick any number less than 4. Pick 3, pick 2, pick 1, pick 0, and ask yourself, what can you say about the slope? And you don't even need to plug it in. You just need to know if it's positive or negative. So we're just trying to figure out uphill or downhill. That's all we really need to know. That's the key idea here. So what do you think? Uphill or downhill? I guess downhill, yep. So if I plug in a 0, I get -8. If I plug in a 1, I get -6. So any of those will work. It's negative, and I like to draw this arrow. That's kind of my own thing. So the height goes down, and the slope is negative. That's the conclusion we're making. So that's the important little step there. I'm using the slope to make all these conclusions. So go ahead and fill in the next one. If you plug in a number bigger than 4, is the slope positive or negative? So sometimes students get confused and I don't know what to plug into, but we're analyzing the slope. That's what we're doing. I don't even think about plugging it into it. I just think about, is it positive or negative? I don't actually calculate it. Yeah, this is positive. So I put in a 6, it's positive or whatever. In fact, I don't like to put in a 6. If I was doing it myself, I would put in a 1,000. Because to me, then it's really clear that 2 times 1,000 is bigger than 8. So I like to plug in really big numbers because it just makes it clear that I don't need a calculator to do it. So that tells me the graph looks like this. That was the whole point of that. There's more than one way to do that. You could take the second derivative and find out that it's concave up. I made a decision this term to just show you one way. But if you wanted to find the second derivative and confirm that it's concave up, that's also fine. Either way, we're just trying to conclude what we can say about 4. So several things we can say now. We can say 4 is a minimum, but that's not what the question asked. So let's kind of summarize for F, just to really talk about every question we could have. We could say X equals 4 is a local min. Again, the question didn't ask that. We could say that F is decreasing or downhill before you get to 4. So it's decreasing for X less than 4. We can say it's increasing for X greater than 4. And what we just did answers all of those questions. Now, this question was asking about when it's decreasing. So the only thing we cared about was this. Are you with me there? Any questions on that? That's that key analysis piece. The same thing you're going to do anytime you're asked about a local, max, or min, or decreasing or increasing. Now we need to do the second question. And that we could have done very quickly. I just was explaining. So the second question is to play the same game with the G and see what we can conclude. Now, interestingly here, if I was doing this, I always like to factor or divide if I can obviously see a simplification. And for me, I know that's divisible by 4. I guess I know that because I've worked with playing cards before. If you've worked with cards before, you know that you can divide 52 by 4 because there are 4 suits. And you may even know if you how many cards are there in a suit. So if you don't have any card players, don't worry. It won't hurt you on this test. But honestly, if I was doing this, I would divide all 3 of those by 4 because I can see it gives me nice numbers. There's 13 cards in a suit. And then if I divide 8, so this is 22. That's not necessary. We'll keep going on the number line in a moment, and I'll explain maybe. Okay. So you can do this and solve this. The answers to this are going to be the same as the answers to this. You can try to factor, you can try to use the quadratic formula. So that's the one, you're going to have to do that at least once on the test, a quadratic formula solving question. So when you're doing the old exams, take a moment and try to do it. I know it must factor because I wrote this test and I like to make it so numbers work out. So it's probably nice numbers that multiply together to give 22. I don't know many numbers that make 22. Only ones I can think of are 2 times 11. Oh, that must be it. But the quadratic form would also give it. So I'm getting two answers, x equals 2 and x equals 11. If you were really unsure if you did it correct, you could come back here and plug in a 2 here and a 2 here and make sure you get 0. Can anybody confirm that? Thumbs up if you got a 2 and 11. Great. So now I'm going to do the same analysis for G. So now I'm going to look, everything we're doing, we're looking at the slope. We're extracting every bit of information we can from the slope. And so I'd like to think about the slope down here and what that means about the height. This is a little bit harder because the function's just messier. Turns out if you can use the factored form, it's easier to plug into. Now, technically, I've divided out of 4, but that doesn't change whether it's positive or negative. Okay, some might be easier. So if you give me a number less than 2, is the slope going to be positive or negative? So go ahead and plug in a 0 or a -1 or a -1,000. Is that positive or negative? Let's try it. So here's the derivative. It's 4. Yeah, we'll see if that's been suggested yet in a second. Kayla, thank you for that. Yeah, positive. So if you want a systematic approach and don't want to have to think about what's positive and what's negative, the other thing you could do is you could try to visualize the graph. I've sometimes taught that, but I was trying to give the approach that takes the least amount of ingenuity. So I would probably plug in 0. That's a number less than 2. And that gives me 88. So it's positive, which means this is uphill. Now let's plug in a number between 2 and 11. Maybe 10, maybe 3, doesn't matter. And here, this is probably the messiest one in here. I probably would use a calculator and see. So that would be 9 times 4, which is 36. Should have my calculator ready. Oh, here's one. I realize I can't see myself, which is probably for the best. Sorry that you guys have to see me. There's my calculator. All right, here we go. So let's do that number. I know what it is, whether it's going to be positive or negative already, but let's see. I got -32. So there I picked a number between 2 and 11. I got -32. So it must be negative between here, downhill. And then honestly, if I was doing the last one, I would plug in a billion. And I can convince myself without even plugging in the numbers that if I plug in a billion, this is going to be way bigger than the rest. That's kind of a cheat. So I know it's going to be positive. You can also just pick a number, 12, calculate it, see that it's a positive. Again, the goal isn't to compute the numbers, it's just to figure out when it's positive or negative. So that's extracting every bit of juice I can out of the first derivatives. So any questions about how I made those number lines? Because that's an important piece. You will definitely have to do this on page 4 of your test, maybe on page 5 as well. That's that analysis piece. That's how we answer any question about increasing, decreasing, local max, local min. Okay, what's the final answer? Good. So now let's finish. Here's what we can say about F. Let's say what we can say about G. So let's just list everything. X equals 2. Well, I'll just have you do a quick call and response, and then we'll answer the question. X equals 2, is that a local max or a local min? I'm looking for local max or local min. This is not part of this question. I'm just extracting everything I can from here. It's a local max. This is why I think my arrow method is the best, because the arrows show you what's happening. X equals 11 is a local min. Thank you. In terms of increasing and decreasing, we can say that for it's increasing when x is less than 2 and when x is bigger than 11. And we can say it's decreasing between 2 and 11. So there's everything we can say about G. That answers all of those questions. So the question was, when are they both decreasing? So when are both of these things happening? And sometimes I find students are mixed up by the logic. So if I tell you the answer is, you have to be less than 4, and you have to be between 2 and 11, what's the answer? Yeah, it's 2 to 4. But sometimes I'll draw the number line so that you can clearly see. So the answer to one of the questions was less than 4. That was this stuff. The answer to the other question was 2 to 11. The only reason I draw that number line is because sometimes that helps people see, oh, when are they both happening? 2 to 4. But it's really just two separate questions, something like this. So there's everything in all its glory. And that's kind of question type 1, something that has to do with analyzing your function. That's probably the most important question type, because that tells us so much information about our graph. It really tells you what your graph looks like. The only thing it doesn't tell you is the actual heights. And if you want the actual height, you have to plug back into the original function. So that's one of the huge values of calculus, is that we can analyze anything and get the quick sense of the shape. Cool. Oh no, I don't know why that happened. Just a moment. Can I leave that? The actual solution is much shorter. I just was explaining. Good, ready to move on. Give me a thumbs up if we're good to go. Raised hand, yes. No. Accidental raised hand. That's good to know the raised hand works. Okay, so let's hit another one. That I would call the first type. So we did that's I'll just classify this as a local max min or increasing decreasing question, because we do all of those the same way. Lovely. And there was one more just while we're here. So that's what we've done so far. Anybody that joined later, you can see what we've done. I'm not going to make timestamps because in the Zoom videos, it's really hard to do that. I have to re-edit the video. So I'll just have this so people can kind of get a sense of when we did what. Okay. Cool, so let's go to winter 2018 3B. Take a look at what that looks like. But that's good. I'm glad the questions have been asked so far because we've hit two, major things we know are coming. Winter 2018 3B. Uh-oh, I already wrote on this. Wait, did we already do that? That was the same question. That shows you where my brain's at. I must have just written it twice. Yay. Maybe there was a different question I miswrote. Apologies if I missed somebody's question. Here we go for winter 2018 6C. If I skipped somebody's, let me know. Skipping that one. Ah, here we go. I think the question was about C. This is an general analysis type question. I think C came up in lecture the other day, but let's talk about it a little bit. Is this it? Did somebody ask this one? This is winter.
Yeah, that was me.
Great, thank you. Okay, so just briefly, since we're here, these two questions here, finding the critical numbers and classifying them, that's what we just did. So these, if you wanted to practice what we just did, this is the same idea as an increasing, decreasing question. So this is a draw the number line, make an analysis question. And it tells you there's two critical numbers. So I can even tell you what the entire solution for this is going to look like. It's going to be two critical numbers. We'll fill in the plus or minus, and then from that, we'll be able to classify them. So you already, this is what I mean by study enough so that you, when you see this question, you know exactly what it's going to look like. This solution is going to look like this. You're going to solve when it's equal to 0, and then you're going to do this analysis. So that's another type 1 analysis question. We can come back and do that, but the question was about part C. Okay. So it's nice to kind of realize out this one. So part C is a global max and min. That's question type 2. Global max min. I have a suspicion that the confusion here doesn't have to do with the fact that it's a global max min. It has to do with the fact that there's this functional notation. So let's, before we do the question itself, go ahead, Sasha.
Yeah, so I understand that like the function is at the top and then you divide it by x squared, but I think I'm just getting the math wrong, so I wanted to see someone like go through it, but it's not really about the concept. It's just I think I'm
Okay.
screwing up my math.
Okay, good. So maybe the simplification. So let's just do this first. And I'm going to write it bigger so I can see. So this kind of mixes. So why I don't like this question as much now is because we don't do as much functional. We do the functional notation stuff that has to do with finding the derivative, and we know that's coming. We don't have as much in the homework where we play games like this, but it's good to know that saying, okay, go find your f function. It looks like this. And I definitely would prefer to write this the way a calculus student would write it, minus 4x squared plus 12x. That's what this is saying. So I'll just put a little parentheses here. And then the question is asking us to take that and divide by x squared. Now you can leave your phone. That is what d of x is. You can leave it like that. You can take derivatives like that. You'd have to use the quotient rule. But we sort of know from our experience doing derivatives that it would be nicer if we could simplify. So first, any questions on step 1? That's what f of x over x squared means. I think part of the confusion is what in the world does this have to do with anything? And it doesn't have to do with anything. It's just a random function. So let's simplify. So the question is, which one of these do we divide by? And this is actually a fact about fractions. You divide each one. You divide every term. Sometimes I do a quick example. So for example, if I did, just before we do this one, a little silly example. If I had 6 minus 3 minus 2 over 6, common error I see is students cancel the 6, which is very wrong. But if somebody's, this better be 1/6, because that's what it is. But if you wanted to break up the fraction, you could, but you'd have to do 6 over 6 minus 3 over 6 minus 2 over 6. It's that thing about if you're going to add or subtract fractions, you got to have the same pie. You got to have the same number of slices. That's that common denominator game. What we're doing, sometimes the problems like this confuse people, is we're just thinking about it the same way, but we're splitting it up. Instead of putting the fraction together, we'd much prefer it was split it up. Okay, I'm just saying that as I think that could be part of the confusion. That really has nothing to do with the global max and min. It's just I would much prefer if this was simplified. So let's simplify it. And I'll do it in kind of careful steps. So I'm going to take the first term and divide by x squared. I'm going to take the second term and divide by x squared. I'm going to take the third term and divide by x squared. So I haven't done anything yet. I'm just trying to, I know I'm going to have to take the derivative in a bit. So I would like to simplify that as much as possible so that taking derivatives will be easier. This is a, one governing principle here is whatever the function is that the question is asking about, you would like to immediately write it in a way that we can do calculus. I suspect that's the bigger confusion anyways. Can we simplify that further? Yeah, this will all be recorded and posted. Probably not till tomorrow because sometimes it takes a few hours for Zoom to process. Once it's processed, I'll post it. Somebody's asking about that. Okay, so keep simplifying. What do we get here? This x cubed, I always think of it as counting, x times x times x over x times x. You're left with 1x. So this is 1/3 x. What's the second term? Tell me in the chat. What is this going to become? -4, lovely. And the last term, how would a calculus student write the last term? Yeah, we'd write, oh, you found a way to type it in. Not easy. 12 over x is a perfectly good answer, but I'm going to write it as x to the -1. Okay, so that really, I think that's an added confusion, which is one reason people are getting stuck on this. There's one other thing we need to talk about. This doesn't have to do with the fact that it's absolute max and min. It has to do with the nature of this function. Okay, so now let's pretend that this is the beginning of our problem. Let me just grab this. So we're going to grab it, we're going to move it down here. I know you can't do that on a test very easily. Okay, so this is our d of x. And now I have a plan. So this is one of these questions. The moment you hit absolute max and min, you have a plan. You should know what the next step is. It should also know what the last step is. So absolute or global max and min, and I'll use the word global on our test. I just feel like that's the word I use more in class. The textbook uses absolute sometimes, so I must have been pulling that from homework. Okay, the end of the question, the main thing that makes it a global maximum question is we don't care what the shape is. So we don't have to do the number line for a global maximum question. We just care about the biggest overall. So the one thing that's unique about those problems is you plug back into whatever the function is you're analyzing. And the things you have to plug in are the endpoints and the critical numbers. The endpoints we already know, the critical numbers we need to find out. Somebody's asking about, am I going to ask this? I do expect you to know functional notation, and there are times when we have to simplify. The main example where this has come up quite a few times, so I probably won't ask this exact question, but there is a situation where this has come up. And the main situation where we've seen this is average cost, because average cost is total cost over X. I think that actually has come up on both my midterms. So that's an example where you had to do the dividing first. Yeah. So in that case, like if I gave you total cost, you have to divide by X and simplify it. Yeah. Yes. This is kind of arbitrary, the way this one was asked. So we have two jobs. One is to take the derivative and find when it's equal to 0. And the other is to plug in our endpoints and our critical numbers and see who wins. So let's take the derivative. So it's nice that we wrote it so that we're ready for calculus. The derivative is 1/3 minus 0. And then the derivative of this term, the negative comes down. So it's going to be negative 12x to the -2. And we want to know when that's equal to 0. The answers tend to come out nice on my exams. If they don't, I usually say I accept an approximation, but it's all relative. What is nice? Is 4/3 nice? Is 5/3, 5/4 nice? There might be some numbers like that. Somebody's asked me that privately. Okay, so I did want to say something here because this happened on both our previous midterms. How in the world do we solve this? Take a moment. Do you have a plan? Because this did happen on exam 1 and then it happened again on exam 2 and people were still mixed up. So you need a plan now that we've seen it here. The moment we see something like this and are asked to solve, and part of the reason it looks bad, part of the reason it looks bad is because of this negative exponent. So this is the moment that I want to stop being a calculus student and I want to turn into an algebra student. That's my own way of saying it. I don't know that many instructors that say it that way, but the moment I'm like, this looks confusing because the negative exponent, I just get rid of the negative exponent and then I multiply everything by x squared. Honestly, if it was me, I'd also multiply by 3. I like to get rid of all my fractions, but multiplying by x squared will take care of it. And so then I'm going to get 1/3. I like to write the numbers first. X squared. You don't have to. Minus 12. That's the whole reason we multiply by x squared. Equals 0, because x squared times 0 is 0. And it's just amazing how that, I always feel like that lifts a weight. Something about getting rid of your fractions immediately makes us feel better. I don't. So anyways, I have 1/3 x squared minus 12 equals 0. So that's that strategy that few people were missing on exam 1 and exam 2, which is if there's a negative exponent and you're solving when something's equal to 0, rewrite it as a fraction and then multiply both sides to get rid of the fraction. That's the strategy. And at that point, hopefully we can solve. This is a quadratic and you can use the quadratic formula, but if there is no middle term, there's a better way. Just get x by itself. The only reason we need the quadratic formula is when there's 2 x's, because we don't have an easy way to get x by itself. If there's only 1 x, we don't need the quadratic formula. It's overkill. Okay, so I'm going to try to get that x by itself. I get 1/3 x squared equals 12. And then I'm going to multiply times 3. I know I'm not doing a very good job of organization here. 36. And then I get 2 plus or minus 6. And so that's the same, we were talking about local maximin. Everything is the same. Local maximin, global maximin, up till right here. And now the plan for what we're going to do with our critical points is different here. Because we don't care whether it's a local max, we don't care about drawing the number line. We just want to know which thing spits out the biggest and smallest between 1 and 12. So you actually don't need both of those numbers. You only need one of them because only one of those numbers is between 1 and 12. 6. And now we plug those in. All right. So what do we get? Did anybody plug in 1? One-third times 1 minus 4 plus 12 times. And honestly, at this point, I would write it as 12 over x. When I'm evaluating, I also don't like negative exponents. I just find I tend to do it wrong. So this is what I'm plugging into. 12 over 1. So I actually think that's not too bad. It's 8 minus 1/3. Whatever that is. 8 minus 1/3. 7 2/3. Not 8 minus 1/3. 8 plus 1/3. And then when I plug in a 6, I get 1/3 times 6 minus 4 plus 12 over 6, which is actually nice because it's 2 minus 4 plus 2. Oh, it's 0. And then when I plug in a 12, I get 1/3 of 12. So even though this looked maybe like the numbers were bad, they're actually pretty nice. I chose the numbers carefully. 4 minus 4 plus 1, I got 1. So I got 8 1/3, 0 and 1. Can anybody confirm? Did you get those same values? I haven't been checking the solution, so yep, I got a thumbs up. Great. So 8.3 repeated. That's the biggest I got. So that's the maximum. Oh, and this one I happen to ask where it occurs. It occurs at 1. I think the reason I asked it this way is I often find students enter the wrong thing. And so I thought by asking for the Y and X, it was clear. But the actual max value is 8.3. It occurs at 1. The min value is 0. It occurs at 6. And honestly, this also tells me what the graph looks like. It just takes a little longer than our first derivative analysis, because now I actually could just go to 1 and 6 and 12 and graph them. So if you're ever unsure, you could plug in your numbers to the original function as an added check of whatever you're doing, because I know this is 8.3. I know that it comes down to 0, and then it goes up to 1. So this does tell me what the function looks like. So it's also a local minimum at 6. All right, do we take care of that? So I'm glad we got to do a global max and min. The main features of a global max and min are this. A global max and min question can be on the test, yes. In fact, if you watch my sneak peek, you know it is on the test. Will it necessarily be this notation? I don't know, what did I say here? This is an analysis question. Not page 2. Those pages like 4 and 5. Let's say what we did there. So that was a global max and min. Again, if anyone missed this, I do a sneak peek in a previous video. This is your final. I talk about this in one of the video I just posted. This is your exact final. But I've blocked off the function. So if you're asking where, you can already see this. I posted it. So I was trying to consider, what does it say? Oh, global min and max. I say that in the video, but so you know what's coming, but I'm not telling you the functions. Spring 23, 2A. Spring 23, 2A. Okay, great. This is spring 23. Did somebody ask this? Do you want to give me a thumbs up or a reaction or a party symbol or something? Okay, good. Did you have a question on this or so? Oh, no, you were just saying it was you. Got it. Find the equation of the tangent line to this at 0. Okay, so what this is really asking you is what is the height and slope at 0? Tangent lines look like this. And a reminder of what goes in each of the places. This is going to be the x value. This is going to be the y value. Another way of saying that is it's the height of the graph. And this is going to be the slope. Now that's always been true about lines since we first learned them. But what's new in this section is we're finding the derivative. So we now have a way to find the derivative in order to get the slope of the tangent line. You can write it in any form you want. I never take off points for someone writing the equation of a line in a different form. Now, in this case, the x value is 0. So it's going to be an mx plus b form, even if you do nothing. So you can write it in any form you want. The point slope form is usually the fastest because no matter what the x value is, once you know the height and the slope, you're done. But I have no problem with the mx plus b form. I like it. So this question was saying, what is the height at 0 and what is the slope at 0? Okay, let's grab the function. I'll write it again. 5x e to the 3x. So I kind of like these functions just for the sheer fact of, do you understand that the function gives you the height and that the derivative gives you the slope? So the height we can get right now. So if you were looking at the graph, you plugged in 0. Let's do that. If I plug in 0, what is the height? So it's going to be 5 times 0, e to the 0, plus the square root of 0 plus 4. Now, e to the 0, sometimes I see people do this wrong, is 1. But since we're multiplying times 0, that part is just 0. This is 0 times this is 0. And this is the square root of 4, which is what? And incidentally, somebody was asking about this in office hours. The square root of 4 is 2. It's not plus or minus. The plus or minus is only something that appears when we're solving. Square root itself is just that number. Okay, so this is going to be 2. That goes right here. So the point of me saying that is, if somebody's asking for the tangent line, you're basically almost immediately done. You should be writing x. You should be writing plus 2. In this case, there's a 0, which you don't even need to write. The rest of the problem is finding the derivative. So don't be scared of tangent line questions. You should know that immediately you can plug that in, which is nice because you can immediately get credit for some stuff. But now we got to do the important piece, which is how do we find the slope? And that requires we find the derivative. And that was really the heart of this question. So this question is a derivative question. And we have 2 terms. And we have something that needs to be rewritten. So let's kind of go through the process of how we do derivatives again. Here's a function. We identify that there's 2 terms, this plus this. So we have 2 completely separate derivatives to do. That's observation 1. Observation 2 is that one of those things needs to be rewritten. It's this square root. So before we even get started, we should be doing 2x plus 4 to the 1/2. Now we're ready to do calculus. This one's already in a form that we can immediately start working. The rest of this is to now do the derivatives. So take a second and practice here, because this is a good derivative that has a couple skills in it. So for those of you that need work on this, take a moment. This is my function. It's now written so that I'm ready for calculus. You need to do this derivative using whatever appropriate rules, and this derivative using whatever appropriate rules. And when you're done, you're going to plug in 0. And based off of lots of discussions and office hours, I've been trying to break this down even more. I'm just going to scratch this out for a moment. That doesn't mean you should skip it. I just want to show you that I don't want you to get confused. I'm going to be working on this problem. So we have 2 problems, this one and this one. So I've had a few people tell me they're getting confused between the chain rule and the product rule and the quotient rule. So I started to think, well, how could I break this down even further? So here's your thought process. If it's just something like this by itself, x to the n by itself, with a number in front of it, let's say, we can take the derivative. So let's talk about the 3 like primitive cases, just to break it down even more. And maybe this, even if you know it, maybe this will help people even more. I would call that a basic case. I would call this a basic example. Those are our 3. Let's review this. Those are our 3 examples that we can do in one step. Anything like those, change the constants, we can still do it. So what's the derivative? This first one, hopefully we can know right away that it's 33x to the 10th. The second one is 2e to the x. And what's the last one here? This is not part of this problem. I'm just doing a quick review. What's that last 7 over x? Yeah. So those are, I don't know what we want to call them. The 3 ones we can do in one step. Now, when I look at these two, they are not one of those. They have to look exactly like one of those. If it's not exactly like one of those, then we have a little more work to do. So this is a weird combination. The first one's a combination of things. The second one's trapped inside of a power. Okay, so if it's not one of these, then your question becomes product, quotient, or chain. But if you want me to break it down even more, I would say maybe the right order is to ask, is it a quotient? Because that's the easiest to see. Is it a big fraction? No. The next question that's probably easiest to ask is it a chain rule? And then if it's neither one of those, it's a product. Because some students were telling me that they were having trouble seeing the product rule. So if it's not one of your basic ones and it's not the quotient, it's not the chain, then it's the product, if that helps. So anyways, when I look at these two, none of them are quotient rule. One of those two is the chain rule, meaning you would immediately start applying the chain rule. And to me, it's easy to see because this is this to the 1/2. So that's a chain rule. And this one over here, it's not a basic one. It's not a quotient. It's not a chain. It's got to be a product rule. So this is the first thing I would do over here. So there's breaking it down again, trying to find another way to say it. Okay, so the rest of this is doing the appropriate derivative. So do whatever you have to do a product rule. Do whatever you have to do to do a chain rule. Does that help?
Why is that?
Break it down.
Sutter wants me to move for an immediate dismissal.
What? You leveraged me into bringing this indictment and now you want to toss it?
I don't want to toss it.
Is that Suits?
He's going to find someone else who will.
What are you doing?
Nothing, I'm just finishing.
All right, I'll hit mute. That sounded like Suits. My son really got into watching that show. But I want to know if I got it right. I only heard it for a few seconds. I feel like I was right. That sounded like Suits. All right, nobody knows what I'm talking about. Somebody had their audio on for a second. Okay, so let's do product rule. First times for the second. All right, good, I got it. My son will be proud of me. 5x, he really got into that. Which is good because it meant he wasn't playing Brawl Stars. Okay, now I did the first, I did the second. The derivative of the first is 5. And now I have an unknown here. So I really do think through derivatives the way I've been teaching them. And this, what happens is I just identify the rule, I start to work, and in the process, I sometimes have more work to do. So it's really good for people that kind of can compartmentalize their thinking. Also just something that math does a good job of getting us to practice. So right now I would need the derivative of the second. So how do we do the derivative of the second? It's actually a chain rule. It's e to the 3x times the derivative of the n-side, which is 3. I kind of would clump this in even with this. We've done this enough that I feel like we could really do it in one step. So that's how I think about that one, but 3e to the 3x. So when all is said and done, I get 15. The question did not ask us to simplify this. In fact, I probably wouldn't simplify it. The question asks us to plug in 0. So that's the derivative of the first term. What's the derivative of the second term? Now we're going to do the chain rule. So derivative of the outside, reduce the power, leave the inside alone, times the derivative of the inside, which is 2. And there is something to be said to knowing you can simplify here. If you do 1/2 times something and then later multiply times 2, the 2 and the 1/2 could just be written as 1. Anyways, the question will be done once we plug in 0 everywhere. So anyways, I'm getting f prime of 0 is 15 times 0. So I won't even go on with that. e to the 0, I guess we could write, plus 5e to the 0, plus whatever this is. I'll even leave the 1/2 and pretend we don't know that we can simplify it. And again, the moment I figure out what that number is, I'm done. It's the slope I'm after. So a little bit of simplifying here, but it does come out nice because this is just 0. What is 5e to the 0? That's one I've seen computed incorrectly quite a bit. It's just 5, yep. And then lastly, I would cancel the 2's, but this is another moment where when I'm starting to calculate, I would much rather write this as 1 over 4 to the half. And honestly, I don't even like to write it that way. I'd much rather write it as 1 over the square root of 4, which is a half. Yeah, if all you do is somebody's asking privately, if we all the only mistake I make is a calculation error, that's going to be a -1. You'd get the rest of the points. This probably would be worth maybe 3 or 4 points, probably 4 points. The way I would write a rubric for this, if that's our question. So this should be in total a half. And so it's going to be 5.5 or 5.5, however you want to write it. A rubric for something like this, and I'll get to your question, it would be, do they have the equation correct? Did they compute this correct? Is their derivative correct? That might be 2. And is their calculation correct? Something like that. So yes, you'd get the vast majority of the points if the calculation was wrong. Somebody did raise their hand for a second. Did we?
Yeah, I have a quick question.
Yep.
So if you don't simplify 5x times 3e to the 3x, because you said to like not simplify it if we're doing it on the test, and you left it in 3e to the 3x or 3e to the 0 power, would that be 3? Do you see what I'm saying?
3.
So like at the bottom when we're doing like
Mhm.
f times s prime, and we have 3e to the 3x.
Right.
Like, see how you combined them to 15x?
Yeah, that's not necessary. It's just, it's more helpful to us as a person doing the computation. But that's not necessary, no. Ultimately, you go ahead.
But I'm saying, wouldn't you get a different answer if you don't simplify it? Because didn't you say like 5e to the 0 is 5? So wouldn't 3e to the 0 be 3?
It is 3, but we're plugging in 0. So let's write what I mean here. So if I let's just grab that term. So 5. So what we got was 5 times x times 3 times e to the 3x. That was what this term is altogether.
Oh, I see. Okay.
Right, because we're plugging in 0 here,
Oh, that's what's
here, this 0 just wins out.
okay.
So it is true that this is going to be 3 and this is going to be 5, but since there's still a 0 in that product, it's still going to be 0.
Okay.
So yeah, that's a good question to ask. Yep.
Okay, thanks.
Yep. Lovely. I'm going to jump back to our list, see how we're doing. We did we did kind of a big derivative, I would call that. So we got to do a big review of derivatives. And we did a tangent line. But a tangent line is really about understanding that the function gives you the height and the derivative gives you the slope. So maybe I'll write that here. I don't know what to call this. x1 plus y1. This is the height at this value, which means we plug into the function. This is the slope at this value, which means we plug into the derivative. If I'm asking a question like that, I'm really asking you to take the derivative, but the main reason I ask questions like that is to see if people understand what's the height and what's the slope, where they go. Wonderful. We're going to go a little while longer. I just gave 8:30 as a rough break. Let's see, there's a question on winter 19 3B. I'll go take a look in a second. And then there's a question about spring 23 number 4. Lovely. So we're going to look at winter 18 number 4. Is that person still here? Oh, Anthony, good question. That could be something I could ask about. So let's I'll add that to the list and see. Finding plus C. You can use any grammar you want in the chat. Winter 19. So let's go and look at winter 18 question 4. Right. Is that person still here that asked this one? Great. So this is a consumer supplier surplus type question. So this is a formula you're going to have on your note sheet. If you want, I forgot to keep referencing this, but if you want a review on what this might look like, that's this third video where I go through that. And again, anybody that's come on later, we don't need to go through all those videos, but if there's one of these topics you need more details on, that would be a place to go, the discussion board, where I have a video on each piece. So in my mind, I'm thinking I need to do this. P1 times X1. That's my own kind of symbolism I gave in class for this. But in order to use that, and that's for the suppliers or producers surplus. So I would have that somewhere so I could refer to it. But in order to use this, you do need the market equilibrium. So visually, if you want this picture again, here's what it looks like. I'm not saying that this matches these graphs. I'm saying this is the general picture. Market equilibrium is what I call, I don't know, X1, P1. And these are two area questions. One area question says, what is this? That's the consumer surplus. And the other question is, what is this? But you don't really need to know those for the formulas, but I'll put this formula here too if you want. The integral from 0 to x1, f of x gx. And these are in the review I handed out as well. But they didn't ask for this. They asked for this. So we need this function, which they gave us. So the main thing here is before I can get started, I do know the supply function. They told me it's 2 plus 0.5x. But I can't really start until I know what the market equilibrium is. So there is an algebra challenge here, which is we need to find where these two things intersect. So we have two equations. One of them is P equals 77 over x plus 1. The other is P equals 2 plus 0.5x. So now we have all our pieces. So this is what a supplier surplus question will look like. We need to do some work now to combine these so that we know what the X and P values are when they intersect. So here's this happens in there's two places where this could happen on your test. So you know you're going to have to do this in some way, meaning two places where you have to find the intersection or combine two equations. It happens on these problems or on those multivariable problems when you're finding critical points. So we need to combine. This particular one is kind of challenging, more challenging than others to combine, but we're still just going to substitute. Substitute and see what we get. That gives me 77 over x plus 1 And now we're going to embark on some solving. And I would say this is something we can solve, but this is one of the more challenging algebra solving questions we've had this term. This happened once or twice in the homework. In this formula, somebody's asking about the formulas. This f of x is the demand. So consumer surplus is about the demand. Supplier surplus is about the supply. So when I say f of x in my formula, f of x is the demand. It's the one on top. G of x is the supply. It's the one on the bottom. Yeah, good question. Okay, so now we have to solve this. I think we did this one in lecture, perhaps. I need to get rid of that denominator. I need to multiply both sides by x plus 1. Unfortunately, that does not immediately solve the problem. It does get rid of the fraction. But now we have to solve this. I'm going to grab some water here. So how in the world do we solve that? So imagine you're on the test and this happens. I think the more, as I was a college student, I didn't really figure this out till my junior or senior year. But I started to say, okay, what happens when I get in this situation? And the more you can have those moments while you're studying, the better the exam will go. You have to let yourself be in the exam. So we're in the exam, we're right here. What are we going to do? We're trying to solve. Let's expand. I think my years of playing high-level competitive tennis might have helped, because there were so many times I was in situations where I was losing. So it's like, what do I do? And then I'd make an adjustment. It still didn't work. Okay, so then we have that. Let's do the other eyebrow. I'm expanding. Let's do the nose. 0.5x squared plus 2. So that's a success. I was able to expand. Now what? Now I see that it's a quadratic. And not only that, I see it's a quadratic that has a middle term. So I'm stuck with basically one option, which is to get everything to the same side and use the quadratic formula. So 0.5 x squared. And I like to write the x squared first. You don't have to. 2.5x. I combined like terms. And what's this last number, just to see if you're still awake? All together, what's going to be in this spot? And be careful because it's a 2 there. And I'm subtracting 77 from both sides. So yeah, negative 75. That's a place where it's easy to make a mistake. You know, I've learned about myself where things I have to check. Sometimes just subtracting these constants is a spot. If you went on and did the quadratic formula and you're like weren't getting an answer that made sense, that would be a place to check. I personally would know to, because the 0.5 is kind of like a fraction. If I was doing this, I'd multiply everything times 2, but let's not use any trickery. Let's just go here. So 2.5 plus or minus. Okay. Negative b plus or minus square root b squared minus 4ac all over 2a. Let's actually do this. I don't want to always skip steps. So if I grab my calculator, what I would be doing is calculating the stuff under the radical. So I'd be doing 2.5 squared. And I would see that I have a minus and a minus here. So it's going to be a plus. So I would do plus 4 times a half, which I probably would have simplified, times 75. And I always write, especially if it's on a test, I would write it down because you always have those situations where you make a calculation error and I don't want to have to recalculate it again. And the bottom is 2 times a half, which is just 1. So that already looks a lot better. And now if I mess up, I have something I can go back to checking. So the next thing I'm going to do is the square root that answer. Kids coming in and out of here. So this is negative 2.5 plus or minus. And when I hit the square root, I got 12.5. So I'm really a proponent of this writing down as you go. It's way better than trying to type it all in and not seeing if I made an error or I did a parentheses. It also just takes all the weight off of me having to worry about calculation. So if I'm using the quadratic formula, I'm calculating everything under the radical, and then I'm hitting a square root. And honestly, if you know me, you know that number is going to be nice. So if it doesn't come out nice, I would stop and recalculate it. Okay, so now I have two possibilities. Negative 2.5 plus 12.5 and negative 2.5 minus 12.5. And really at that moment, I can see it's just the positive I want. Because we're talking about this supply and demand. So I think it's 10. X is 10. So that's you do want to, when you're practicing, you don't want to use some other resource. You want to actually try to do it in your calculus. This is because you're building these skills of avoiding errors as part of your studying. That's part of just putting yourself in the exam. Would I be able to do this? How in the world am I going to get P? Plug it in. You're going to plug it into both places. If you follow my advice, you know that you're going to plug it in here and here, especially if it's a test. Because you don't have WebAssign to check it for you. You don't get 5 submissions. So you have to check it yourself. So I'd plug it into both and make sure I get the same thing. So one of them would give me 77 over 11. That's what happens if I plug into the first one, which is 7. And the other one would give me 2 plus 0.5 times 10, which is going to be 2 plus 5, which is 7. And I find that very satisfying when they match up, because then I know I'm right. Okay, so that was kind of its own, that really is not typical of consumer and supplier surplus. It was just the nature of the particular problems we were given, the numbers and functions. But now I'm ready to wrap things up. So I can say this is a 7, this is a 10. I need to integrate from 0 to 10. And from there on out, I'm calculating a definite integral. Sorry if I made it too small. I think you can zoom in on your end maybe. So this is going to be 70 minus whatever this integral is. I'm going to put some big parentheses here so I don't get mixed up. I need to remember to subtract whatever I get out of this. So I'm going to integrate. 2 becomes 2x. This becomes 1/2 x squared. I copy the 0.5. Now I'm going to plug in 0 and 10. So now I need to plug in 10 everywhere. And then when I'm done with that, I'll plug in 0 everywhere. So 70 minus 2 times 10. Plus, I think this is 0.25. 10 squared. And then typically you do need to remember to plug in the 0, but in this case it's just 0. So it's kind of a waste for me to write this. So there's a reminder of how we compute definite integrals. And I could ask you that on the first page of the test. You'll definitely have to do it if you do an area or consumer surplus. And that was that: find an antiderivative, plug in the endpoints, subtract. That's what we call the fundamental theorem of calculus. Okay, so then if we're taking this all the way to the end, it's 70 minus, and this would be 20 plus 100 times 0.25. So I think it's 25. You can see how much I find that I do better if I don't use my calculator. All right, this is 25. Does that match up with what other people got? Like, I haven't been checking the solutions. I assume that if I make a mistake, somebody would have told me. Any confirmation there? Thumbs up if that matches. while you're checking. Let me grab this here. One of your classmates gave me this. Pretty spectacular. Permanently in the background. I forget which type of bird he said this was from Mexico. Trying to add to my background. All right. Let's go. So that was consumer supplier surplus. Lovely. So we had supplier surplus. Okay. Again, if you have somewhere else to go, I'm going to stay for a bit longer, probably at least till 9. I want to get as much as we can get done here. Winter 2019. Leo is holding some office hours from 1 to 3 on Wednesday. I can't promise. I'm going to try to pop in there, but I have a bunch of meetings the next 2 days. So anyways, winter 2019 3B. Here we go. Got it. Is this person still here? 3B, this is winter 18? I've forgotten now. Winter 19. Winter 19. 3B. Give me a thumbs up if you asked this question. Maybe nobody did. Okay, great. You asked this long ago. Thanks for waiting. Very patient. So here's this function. It gives you this picture. Now, the picture itself doesn't mean you skip it. The picture is trying to help. So this is good. I did say you skip those graphical questions. What I mean is those graphical questions where you have to estimate area from the graph. In this situation, the graph is trying to like just give you a visual of what you're dealing with. The question itself is asking for the derivative, the height, the slope, the tangent line, and then it has us do something with the tangent. So I would call this question fair game for the test, which might be what you were going to ask. Sorry if I stole your thunder there. Yeah. For question 6, there was a question and somebody's saying, look up above. But I might have to come back to that. We'll come back to that and let's talk about this for a second. Sorry, Dee Dee, if I missed a question. Okay, so let's take a look here. So the main thing is this is a quotient rule question, which is good because I don't think we've done a quotient rule problem during this review. So let's hammer that out real quick. This will be a quicker question than the previous ones. So I would like to take the derivative. Hopefully we don't need that hint. So we're going to do denominator, derivative of the numerator, minus numerator to the denominator of the denominator squared. And I really like when I'm doing the quotient rule to write down the denominator squared here. And write down the denominator here. That's just sort of a visual check that there should be denominator and denominator squared. So you can quickly see, okay, are those in the right spots? Then there should be a minus. And then there should be the numerator. So those are all things you could just sort of quickly stand back and say, did I do denominator? Did I do, I don't know why I made that look weird. And then I need a couple smaller derivatives, which hopefully we can do fairly quickly. You could also rewrite it. Somebody's asking me privately, could I take the original function and rewrite it like this? And then do the product rule? That's also acceptable. I find in these situations that might lead to more likely having an error because of the negative exponent. That doesn't have to mean there's going to be an error, but I've just found over the years that students make a few more errors when they do it this way. But I'm perfectly fine as long as you don't make errors. Okay, so now let's do the derivative of the numerator. So this is 2, yep, times, what's the derivative of the denominator? This one kind of looks funny. The derivative of the denominator is 2x. So it's weird because there's 2x's. Okay. Before we simplify or do anything else, let's think about what the question is asking us. So the question is asking us, what is the height at 1? And the height at 1 is talking about the actual function itself. So you need to plug in a 1 here and here. So this is more of just a general understanding question. If someone gives you a graph and says, what's the height at 1? You plug in 1, which is going to be 2 over 6, because it's going to be 1 squared plus 5, so it's just a third. What is the slope at 1? The slope at 1 is going to be this. So we're going to plug in 1 here, here, and here, and here, and here. So I think that's going to be, let's do a little calculation. 1 plus 5 is 6 times 2 minus 2 times 2 all over 6 squared. So you can see the value of little bits of simplification. That's why I don't have to reach for a calculator, because I did 1 squared plus 5 is 6. So you have to trust yourself a little bit and do those small calculations. And in doing so, it just makes your life so much easier. Okay, so 12 minus 4 over 36. So anything I can easily simplify, I do in each step. And that's going to be 8 over 36. And I feel like that begs me to simplify because I can divide top and bottom by 4. And that gives me 2. Top and bottom by 4. 2/9. My brain stopped for a second. 2/9. But you could leave it as 8. I wouldn't take off for 8/36. The one thing about the picture is it actually helps us here, because if I would have gotten a negative slope, I would have known something is wrong. Now it's not to scale, so don't worry but a slope of 2/9, a height of 1/3, it makes sense at least that they're positive. I think the reason I did that is I was trying to remind people these are the things you need to get the tangent line. So to reiterate something from earlier, how do we give the equation of the tangent line? Well, if you know all these things, you're done. The tangent line looks like this. And the 3 numbers above are the 3 numbers you need. The slope goes here. The x value goes here. And the height goes here. That's it. So the value here is that we can find the height and the slope and the tangent line for any function anywhere. That's one of the things that's nice about calculus. All right. The second question asks us to do something with one of those functions. So let's just say something about the next part. It says there are 2 dots in this picture where it has a horizontal tangent. So that sounds a little more complicated than it is because there's lots of words there. But it says there's a point right here and a point right here where you have a horizontal tangent. What does that mean? It means you're at the highest point and at the lowest point, but that's hard to answer. If I say, here's a formula, when is it highest and lowest? That's not easy to do. So there's a better way to ask the question. Instead of talking about the height, what can we say? I don't want to know when the height is highest or lowest. I want to know when the slope is 0. And that's why it's really nice to be able to have a height and a slope, because some questions are easier to answer with height, some questions are easier to answer with slope. Here, the slope is 0. That's why that gives us the bumps. So this was just saying in words what we've been doing all term, which is I want to know when the slope is 0. Now there's a challenge here, which is, okay, but how in the world do we do this? Maybe I'll simplify this a little bit. 4x squared. And I think that just looks worse than it actually is. How would you find when that's equal to 0? Let's put ourselves in the exam. Yeah, this might be trickier than something I would ask, but let's just look at it and put ourselves in the exam and we're faced with this. And we need to find an x value when that's equal to 0. What would you do? Yeah, you get rid of the bottom. We're going to use our same strategy. Somebody said that privately. So I'm going to multiply everything by the denominator. There's also a general comment, which is, and sometimes people don't understand this, but if you have a fraction equal to 0, what does that tell you? We haven't had this come up this much this term, but it's something we should know. The numerator is 0, yeah. If the denominator is 0, you get an error. So this does not mean the denominator is 0. You can just multiply both sides by b. This means a is 0. Sometimes people don't realize that. So when I look at this, I go, oh, it's not as complicated as I think. In fact, I really want to distribute that too. So the top has to be 0. That means 2x squared plus 10 minus 4x squared has to be 0 because that's the top. And that is something I sort of like. 10 minus 2x squared is 0. So this is one of these equations that looks worse than it is. If you just kind of take a breath and say, what can I say from here? It's not so bad. That gives me 10 is equal to 2x squared. That gives me 5 is equal to x squared. How do we solve that? This is not a nice number, but it's easy to write. We know that there's two answers. I think that's why I gave the graph years ago and asked this question. As I said, maybe it's a little more than I would ask now. But I was like, well, we see there's two answers. We actually see their symmetry. What are they? Yeah, they're plus or minus the square root of 5. So a problem like this is sort of saying, it doesn't matter that the formula is messy. We can do all the same stuff. In fact, this is the situation where calculus is more helpful because I don't really know what that graph looks like until I do the calculus. And once I've done the calculus, I know, well, there's two bumps. And I could do more analysis. So calculus is very good at analyzing things like this. And that's because it gives us the slope, which allows us to answer more questions. All right. So I think I asked a question like that because it kind of gets to the heart of where we've been going. But that mostly was a derivative question. Good question. So I would say that was a quotient rule. And a bit of an understanding of what does the derivative represent. Yep, have a good night. He's leaving there. We've done pretty good. We've hit most things. Spring 23, number 4. Yep, spring 23, number 4. Let's go take a look. That was 3. That was 4. Ah, thank you. I know this was asked on the discussion board as well, so let's see where this takes us. This is spring 23. So I think I said in my sneak peek and in my preview that something like this would be on page 5 of the exam, meaning something to do with business applications and analyzing functions. So if you're worried about this, the place to go would be the part 5 review. If you want to get a sneak peek of what's on the part 5 review, here it is. That's what I talk about in there. So before Oh, there's a question about 4. We don't ignore the denominator. It's just the denominator. If you want to know when a fraction is equal to 0, it only can happen when the numerator is 0. That's the only way fraction can be 0. Okay, so here's the, if you want more of this, before we get into that problem, because I know the questions are going to pop up. Here's what you have to remember. Really, this is all you have to remember when it comes to our applications, because I've already promised it's going to be a business application problem. So we have the revenue side of things. And for the revenue, we don't really talk about average revenue because it has a special name called price. So anytime someone gives you price, you multiply times quantity. That's your revenue. So at one point we sort of talked about this in class, and we said if anybody says price or there's a formula for price, immediately multiply times X, and that's your total revenue. And we made a comment that total revenue at 0 is always 0. So this is going to be on our note sheet. I'm hoping you put it on there if you don't know it. I'm hoping we just know it, but in terms of cost, there's more we can say, but we know that the total cost is the variable cost plus the fixed cost. The fixed cost is the total cost of 0. It tends to not be 0. That's the other side of the story. And visually, here's kind of a typical picture of total cost and total revenue. So again, I go into that in more detail. I just wanted to say that up front before we get into the problems. I know some of the questions stem from this. And profit is revenue minus cost. The main thing we've been doing this term is using the marginal revenue, marginal cost to analyze what's happening with these functions. And in particular, we found various things. We found that when these two things hit, that's when your functions are furthest apart. And in particular, let's just see if anybody's still here. This right here is your worst negative profit. And this right here is your maximum profit. So typically when we have something like this, we want the second answer, but in particular, we want where you switch from profit going up to down. Anyways, that's that story. Oh, Nuri, you asked about that question again. So keep it there. We'll talk about that in a moment. Okay, so now let's go back to the problem. So the main things to remember is revenue is price times quantity. Profit is revenue minus cost. And we need to remember this MR equals MC business. Okay, I think now I've forgotten which exam we were on. We were on. Why are you doing this to me? Spring 23, number 4. Okay, so that's what we should have going into this problem. So then they say, well, they say demand curve. Well, that's just a fancy way to say price, but then they say price again down here. So the moment we see that, we're itching to do something. They're telling me the selling price. What are we itching to do? And I think maybe some people are confused by some of these other pieces. I gave some information like to help out with the problem. This wasn't meant to be confusing. But the moment you see price, you should be thinking, I want to do price times quantity. Yep. So we should be thinking immediately. So that's part of preparation, this problem. Price times quantity. And that's just formalizing what you'd have to do. This is saying if you gave me a particular price, I'd have to figure out the quantity, I'd compute them both, I'd multiply them, and that would tell me how much money I made. Okay. And so I'm going to expand this out. X minus X to the third. This is what happens for a demand curve, right? There's some sort of balancing between the price and quantity we're trying to figure out. The moment we have this, we now can find the marginal. So from here on out, it's really, there's hardly any business left in this problem. In fact, the only thing you really needed to know business-wise in this problem was revenue is price times quantity. From here on out, it's just an analysis question, like the other questions we've been doing about max and min and stuff like that. Okay, so hopefully that puts everyone at ease about what it is you actually have to remember. There's not a lot from there. Okay, so how do we get the marginal revenue? We're going to take the derivative. This is going to be 108 minus 3x squared. And then the rest of the questions are, so this one's saying largest possible value from 0 to 10. That's one of our 3 big questions. It's a global max question. And it's asking about revenue. So now we have a plan of attack. Global max questions, we plug in the endpoints. So we're going to need to figure out what these are. And we also plug in the critical values. How did I know that I'm working with total revenue? It's a common question I get. That's because it says largest possible total revenue. So whatever it says largest possible of, that's your function. So in your head, think about what is the next thing you would have to do here for a global max question. So I hope you're seeing here that the application piece of it is not as big as it seems. So we need to take the derivative of total revenue, set it, find when it's equal to 0. If we can find other values, we're going to plug those in too, and then we're going to see who wins. So I need to take the derivative of total revenue. Luckily, we've already done that. I'm going to set that equal to 0. I think this probably comes out nice. Is 108 divisible by 3? This is something I find not very many people know, but if you add the digits, yeah, and it's divisible by 3, then the original number was divisible by 3. How many of you have seen that? It's actually really valuable. I do it all the time. Like a 52 card deck is not divisible by 3 because 5 plus 2 is 7. I have a video on that if you really wanted to know why divisibility tricks work. Okay, so this is divisible by 3. We know about divisible by 2 because we do it all the time, but it's weird that we don't have divisible by 3 in our head. But now I got to think about how is it divisible by 3? I get 3, I get 16. But the fact that I know it's divisible is helpful to me. And so that gives me plus or minus 4. So then how do we finish? We take all the numbers that are between 0 and 10, which are 4, and plug them in. And so we will be done the moment we do these 3 calculations. 108 times 0 minus 0 cubed. 108 times 4 minus 4 cubed. 108 times 10 minus 10 cubed. I suspect this is the maximum. So it's going to be 4. Oh, there is this added confusion here, which is the question wants the corresponding price. I remember this exam. This is what everyone missed. Not everyone, but a large number of students lost a point here. Let's see. What did they get? When you plug in 4, what did we get? 108 times 4 minus 4 to the third. This was 368. Oh, my division was wrong. I got what you're saying. I didn't understand. I know it's divisible by 3. Thank you so much. All right. Lovely. Whew. Thank you, thank you. 6. All right, let me do the correct calculation. 108 times 6 minus 6 to the third. Okay, that's 432. Thank you for speaking up. Okay, if I remember correctly, let me get back to what I was about to say. A lot of students put 432 here, but 432 is not the price, it's the revenue. So if the question said, what's the corresponding revenue? You would say 432. So I think the reason people miss this is just because it's natural to take that number, but the corresponding price is what you get from the price formula. I think I was surprised when I gave this test. I didn't mean it to be confusing. I just thought it was interesting to ask what's the corresponding price. The corresponding price is 72. But that's not about the process. That was about interpreting. The process for global max question is find the critical points, plug in the critical points and the endpoint. And that should be the plan in our head. And thank you for catching my error. Not everyone can see the chat. Well, most of the chats are private, so. But somebody caught my error there. The last part of this question doesn't really have to do with the rest very much. Consumer surplus. So that's a formula. This one tells you the market equilibrium is at 3, asks you to find the consumer surplus. Can we jump back to, I know there was at least one question about multivariable problems. I don't think we've done one of those yet. Can I leave that one? All right. How did I get 72? So this was at the end we figured out, and I should have written this out. Sorry, because of my mistake. I'm writing over these things. So when I plugged in the 6, I got 432. When I plugged in 0, I got 0. When I plugged in 10, we get something else. 108 times 10 minus 10 to the third. I got 80. So this is how much revenue you get, and this is the maximum. So what we learned from that is when you sell 6 items, I don't know if it was 6 or was it in hundreds. Let me look. Items. When we sell 6 items, we get the maximum total revenue, which is $432. The question said, find the quantity and the corresponding price. Neither one of those is the price. And so we're like, well, what in the world is the corresponding price? And that's when we'd be scratching our head. Somebody's asking about this, but to find the corresponding price, we'd have to go find the formula for price. Where is that? Part of the problem is you can't see it right now. Now you can see it. Now you can't. Now you can. So this is the corresponding price. So if you want the corresponding price when X is 6, you have to plug it in there. And that's what I calculated. 108 minus. So that was this little added challenge, which is, what are they asking for? And that was 72. I think, unless I calculate. Now I don't trust myself. Does that answer the person who asked that question? Yeah. All right. Great. Okay. So I would call that an application problem. PR and price and global max min. And then we have these 3 questions that have been bumping around the chat and I've been missing here. Finding plus C, horizontal point of inflection, and multivariable stuff. I think those are the few questions that have popped up throughout that I want to make sure to finish up on, and then maybe we'll call it a day there. Finding plus C can happen in the constraints of what we're dealing with. Let me just think about our second midterm. On our second midterm, we had a problem where we were given like MC of X was, it was something like 62X plus 40. And we were told that the total cost at, I'll just make up a number, at 2 was 50. What if I ask you to find total cost? So that's something we did on exam 2, and that requires this finding plus C. So that's constrained within sort of the questions I could ask. That is something we would need. It would be part of what we need to do because we're doing an antiderivative. So anytime I give you a derivative, in the main situation where that could happen is where I give you marginal cost. We need to integrate. But when you integrate, what do you get? So this becomes 1/2 x squared. So this is going to become 31. I don't know why I picked such big numbers. 31 because it's 1/2 x squared. This is going to be 40x. And then we're going to have a plus C. So to answer that question, let's sort of be practical here. How do we find that plus C? What do we do with this initial condition? You have to plug it in. So we have to say when this is 2 and this is 2, the thing that comes out of this needs to be 50. So these numbers are terrible, but 31 times 2 squared plus 40 times 2 plus C has to equal 50. And since I made up these numbers on the spot, in fact, this is really unreasonable because we're about to get a negative. Now I can see. So if I could go back and change my number, I would change the 50 to a 500. This is how you write an exam. Okay, so let's pretend it's a 500. I hope that that works out, but we'll see. So now I'm going to do 31 times 2 squared plus 40 times 2. Okay. This all came out to be 204 plus C is 500. And then you could do 500 minus that answer. And I get C is 296. And the conclusion would be that total cost is 31x squared plus 40x plus 296. Only 2 because the problem gave me that. I made up these numbers, but the initial condition here was when x is 2, the output is 500. Often the initial condition is at 0, but you got to use whatever numbers they gave you. So this one said if you plug in 2, you should get this. Yeah. So I chose that on purpose because we're so used to 0, but there, I think on the last test I did this as well. So it's important to realize when you're plugging in an initial condition, you're plugging in an x and a y. And then from that, you're solving for C. That's what that was. Okay, so that's the plus C business. Okay, so now let's talk about the horizontal point of inflection. I think the question about this was because I show in the outline that that's there. Horizontal point of inflection is one of the possibilities that can happen. Let me, here's what I'm going to do to answer this question. I'm going to go here. I think you could still see this. Can you see my materials page? I'm going to go to this review because I know I have an example here. Okay, good. It's still showing. This is my review of those ideas of max, min, all that stuff. Okay. So I'm going to scroll down to this example rather than make one up. So if I take that function, I'll write it over here. Oh no, come on. Here we go, I got it. Is it going to stay up front? It will. I hope. Y equals, can you still see that entire window up front? I downloaded a tool to allow me to do that. Here we go. So let's say we want to analyze the critical points for this function. Let's practice this one last time. So here's this function. Let's call it f of x. Let's take the first derivative. Let's set it equal to 0. Let's solve. Now, part of the reason we don't ask as many of these questions is because they tend to come up more often in situations where it's harder to solve. But let's try to solve this. We can factor. So this is 4 times x times x times x minus 6 times x equals 0. The reason I'm writing it that way is to make it easier to see what the solving is. So what I see is both of these things have 2 x's. And they're both divisible by 2. That's less important to see. So I'm going to factor out an x squared. And when I do that, what's going to be left is 4x minus 6. So this function has 2 critical numbers. What are they? Let me know in the chat if you're still here. There's 2 critical numbers for that function. And this is to answer this question about horizontal point of inflection. And the horizontal point of inflection does not make you change. You're still going to do the exact same process we did on all the local max increasing d. It's just it's a word of conclusion. So I want to get us there. So let's say someone says, find and analyze all the critical points for this function. So what are the 2 you're getting? So this means either x squared is 0, that's one possibility, or 4x minus 6 is 0. So that gives me x equals 0 or what? $1.5, great. Okay, so now let's do our analysis. So we're going to draw a 0, and we're going to draw 1.5. And then we're going to look at what happens with the slope, and then use that to make conclusions about the height. The slope is this. In fact, it's this, but it's probably easier to plug into the factored form. So now let's come over here, maybe in the margins, x squared 4x minus 6. And I'm going to plug in a few different things to it. See if it's positive or negative. And there's a point to this, but we're doing this analysis. We're trying to figure out, is it a local max? Is it a local min? Or is it a horizontal point of inflection? So again, that doesn't change anything about what we're doing here. So I'm going to plug in a number less than 0. So how about -1? And that gives me +1 times, because it's -1 squared, so it's +1 times -10. So that's negative, which means it's downhill. Okay, let's play the game again and use a number between 0 and 1.5. How about 1? That gives me 1 times -2. It's negative. Well, that's kind of weird. We haven't had very many examples of this because we've been dealing with fairly straightforward functions. This function decreases and then decreases again, which could definitely happen. And then let's plug in a number bigger than 1.5. How about 2? So that gives me 4 times 8 minus 8 times 2, positive. So at the end of this, we have a name for each of these. So what do we say, just to see if you're with me, what do we say about 1.5? What is it? How do we classify it? It's a min. This one right here is not a min, and it's not a max. Our book has a special name for things that are not a min and not a max, and that special name is horizontal point of inflection. So that's all you need to know about that term, is that if it's not a min or max, you would call it a horizontal point of inflection. Now, what does that mean? It means it's like a chair. So we have min, we have max, and we have 2 types of chairs. I'll give you credit if you say chairs. Why I say chairs, because to me, if you put a person in here, it looks like a chair lounging this way or that way. Here, I'm going to show you a picture of this thing. Looks like this. So it has two different, it has this point here at 0, which is, the reason we call it a horizontal point of inflection is because it's horizontal and it's a point of inflection. So it's not a very, it's a name I don't see very often in other courses, so I don't emphasize it as much, but it is good to realize that that's a possibility. So when I'm giving you a question and I say find and classify the critical points, I have to say, then give it a name. That name could be local max, it could be local min, or it could be horizontal point of inflection, but it doesn't change how we do things. Does that make sense? That's what that was about. So point of inflection, whenever it changes from a smile to a frown in any way, I'm going to do a quick grab of this and let's go over here. Just so I can draw on this. Here we go. There's our graph. So if I'm standing over here, it's part of a smile. The way I can see that is if I draw a tangent line over here, the tangent line is below. So anywhere over here, we're part of a smile. If I'm standing right here, I'm part of a frown. So what I mean by part of a smile is this little segment here is like this. Any part of a smile is concave up. Part of a frown, that's what's happening right here, concave down. And if you switched from a smile to a frown, somewhere in between the smile and the frown, you changed. It happened right here. We call it an inflection point. Inflection points, the study of those, that's the second derivative stuff. It just so happens that this is an inflection point and it's horizontal. That was that terminal. Horizontal meaning the slope is 0. So this is just the name that our book gives to this situation when you switch from decreasing flat, decreasing again. So point of inflection is a place where you change from, how you're from accelerating to decelerating, so to speak. Let me shrink this back down. It's the wrong button. It didn't work. Guess I don't know how to do that. There we go. All right, that's that piece. So basically, it's not really something to worry about, but it's just good to know that that's the name for that situation. And then we didn't do any multivariable problems. Do watch my video on that if that is a worry, but there was a question. Let me see if I can find one here. Right. So here the question that somebody's asking is, what's this stuff about again? Right here. The quick version is this was when we were interpreting, but if you just want a quick answer to this, you go, the numbers are 3 and 4. The numbers we're approximating near are 3 and 4. And then you have to identify which variable is changing. And in this case, the variable that's changing is x. And that tells me the partial with respect to x. So quick answer to this is plug in 3 and 4 to the partial with respect to x, and that's the number you're going to put there. Does that answer that question? Somebody was asking that. I'm just scrolling back through to see what else I missed. Cool. So we're going to end in just a couple minutes here, but that's it. We did 3 hours, 2.5 hours. And we hit quite a bit of stuff.
Hey, Loveless, I just had a quick question about one of the answer keys for the winter 2019
Yeah,
exam.
let me pull it
I
up
just want
here.
to confirm my answer. I think it was 6B, it was not circled whether it's concave up or concave down or neither.
Ah. Let me see here. Oh, you're right. So let's see. Mystery piece. Oh, there's a reason. We know I'm running into my chat window. Just a moment. Grab it here so I can write on it. Actually, I don't even think I need to do that. We can see it directly. Let's just talk about it. So actually the fact, well, what did you think? Concave up or concave down?
I had them like both positive on either side of 3.42.
Yeah. Yep. And there's an even, that's right. It's concave up. This is kind of an unusual question because usually we do the full analysis and we draw the number line. In this particular problem, it's unnecessary because they already told us what the second derivative is. So there's a difference between trying to find all the places where it's concave up and concave down and figuring out what's happening at a particular value. Since they already told us it's going to be equal to 5/3, and because 5/3 is positive, we can immediately say concave up without even looking at the values at either side. So this is different than like a question that says find. So really, the moment that they said it was equal to 5/3, we knew the answer was going to be concave up, even before we solved the question. That's kind of a different sort of question, but it's got to be concave up because it's a positive number. If you check the values on each side, that isn't wrong, but we didn't have to do that because. So let me see if I can find another concavity question that's more typical on another old test. Not there. Nope. Did I have one? Well, I would definitely have one on an old midterm. Like this old midterm says, is it concave up or concave down at 1? Now, since they told us the number was 1, we actually don't have to draw the whole number line. We just have to plug in 1 and see if it's a positive number. So it was kind of like that other exam because it was just asking about one value. But can I find a place? Here's one that asks something like this. So it says, here's a function that has one point of inflection, find it. And here would be where maybe you'd want to do the analysis to know what's happening before or after. That's a more general question. So yes, your answer is right. It's concave up, but there's a little bit more to the story.
Thank you. And also just for 6C, I was a bit confused when you're why x equals 15 was chosen other than x equals 1. Just it was like talking about like I think the profit being maximized. Is it just because like the quantity is bigger at 15, so you would choose that x value?
Yeah, you're talking about this 6C right here.
No, the winter 2019 one.
Oh, sorry. How did I skipped away. Winter 2019, 6C. This here?
Yeah, like you get x equals 1 and x equals 15. And then you like choose x equals 15 to plug back into the original equation.
Oh, yeah. So that's you did MR equals MC, right? And you got these two answers. This, right, there's a little more depth to what's going on there. And it has to do with kind of the general story. Now, this isn't quite the picture you had. I think in that problem, marginal revenue is like a line, but let's pretend this is the 15 and this is the 1. Those are those two values when MR equals MC in that problem. We haven't had this happen very often, so that's part of the issue. Both of those correspond to places where total revenue and total cost are far apart, but one of them is really bad and one of them is really good. The first one is the really bad one, because that's going to be when your cost is furthest above your revenue. It does correspond to when slopes match, but this first one corresponds to the worst negative profit. In general, when two derivatives are equal, it's when you have the biggest gap between the functions. So what happened in a lot of the homework questions we did is we got one negative and one positive, so it was easy to figure out. What happened in this question is we got these two answers. What we really want is this transition point where you switch from, we really want marginal revenue to be above marginal cost, because that means your next item is going to bring in money. And we want to keep doing that until we get to a point where that stops. So we always want the place where you stop MR being above MC. So yeah, that was a deeper thing happening. I probably need to go back and add more to that solution, because we used to talk about that more, and there aren't as many problems like that in the homework. But that's why I picked the second one, because the first one's actually it is an important point, but it's the worst negative profit. So yes, let me pull that up right here. Yeah, so this second one is the one where you switch from marginal revenue being above to being below. But in general, if you just want a quick rule that gets you through, if you saw this again, if there's two positive answers when MR equals MC, it's going to be the second one. But that's a little less likely to happen. Let's see, was there another one? Thank you all. I think we're going to call it quits here. Thanks for being here. Keep asking questions. You can still ask questions on the discussion board, but also you can go to those in-person office hours 1 to 3 on Wednesday. And I hope to make an appearance. I don't want to promise when I'll be there, because I know I have meetings before, after, and during. So I'll either be at the beginning or end. All right. And I'll post the video later. Have a good night, everybody.
Thank you.
Thank you.